Good morning. We're going to start our day talking about stoichiometry. Stoichiometry, the prefix stoich comes from Greek. It means element. Metry means a process. So basically, this is a process of figuring out elements. And what you're basically doing is figuring out how much of something is going to react with how much of something else. Okay? It's just simply mole ratios. Okay? I like to think about s'mores. If you think about s'mores, you need 2 graham crackers, you need 1 marshmallow, and you need 1/4 of a chocolate bar, which is, chocolate bars are usually in 12 little squares, so that's 3 squares. So I like to say that, okay, is this going to work today? All right. I like to say, if you have 2 graham crackers plus 1 marshmallow plus 3 chocolate pieces, that equals 1 s'more. So stoichiometry is simply ratios. And for whatever reason, when I do food, everybody gets it. As soon as I start throwing elements in, nobody gets it. But stop and think. If I have 10 graham crackers, how many s'mores can I make? Well, 2 is going to make 1. 10 is going to make, it's easy because you can all do that in your head, 5. How did you do that in your head? Well, if you do a simple ratio, 10 is to 2, as X number of s'mores is to 1, you can cross multiply and you get 5. If I told you that I had 70 chocolate pieces, how many s'mores can I make? 70 is to 3, as X number is to 1. So solve, divided by 3, and that would be what, 23? And a part of 1. So you'd have some extra chocolate to eat, which is always good. Okay? That's all we're doing. We're just looking at ratios. So let's start with our first example. Now we need to understand what the coefficients mean. Coefficients are, tell us that you have 2 atoms of hydrogen reacting with, or not atoms, molecules, excuse me, reacting with 1 molecule of oxygen to make 2 molecules of water. But that can also mean 2 moles. It can either mean 2 molecules, it can mean 2 moles. Okay, so this is the standard ratio. If you have 2, it will react with 1. So if you have 4 moles of hydrogen, it will react with 2 moles of oxygen. Okay, so once again, if we know that it's a 2-to-1 ratio, and I tell you that I have 18 hydrogen moles, 18 is to 2, as X is to 1. Now, there's a simpler way to do this that's going to make, I mean, this is actually the way I learned it, okay? But we can use the rail fence method and make life much easier. And in order to do that, we're going to use a special setup, okay? What we're going to do is we're going to talk about our known. That's what's given. And in this discussion, 18 would be our known. And we're going to talk about our unknown, which is what we're solving for. And we're going to multiply that known times the ratio. Now, I'm going to go back here and I'm going to change colors. I'm going to change this to green. If I set this up, 18 is to 2, as the unknown is to 1. And let's do yellow here. If I rearrange this when I cross multiply, it would help if we get 18 times 1 is equal to 2x. Divide both sides by 2. We get x is equal to 18 times 1 divided by 2. That 18, remember, is our known. 2 is our known amount of coefficients, and 1 is our unknown coefficient. Okay? See this relationship. You've got the known molecule, and you multiply it by the ratio of the known coefficient to the unknown coefficient, that will equal your unknown amount. It's just cross multiplication, but this is much easier to use and do math with. All right, what I'd like you to do, if you have highlighters, I'd like you to get highlighters out so you can do this. If you don't have highlighters, if you have a different color pen, you can do that. Otherwise, in class, when we practice tomorrow or next week, I will have highlighters for you. Okay? So, we're going to start with this first equation. The question says, what is the mole ratio of methane to oxygen? Okay, methane is CH4. Methane, oxygen is, of course, O2. So what is the mole ratio of methane to oxygen? We write ratios CH4 to O2. We have a 1 to 2 ratio. Okay? The next question, what is the mole ratio of carbon dioxide to oxygen? Carbon dioxide, if we compare, we'll use yellow again for carbon dioxide, green for oxygen, CO2 to O2, we have a ratio of 1 to 2. Okay? That's all we're doing is finding ratios here. The next question, what is the mole ratio of ammonia to nitrogen? If we have 4 ammonias and we want to compare to nitrogens, we have a 4 to 2 ratio. What's the mole ratio of water to oxygen? We have 6 waters and we have 3 oxygens. We have a mole ratio of 6 to 3. Okay? So you found those ratios. On to the next page. All right, so now we're going to write and balance the equation. Iron 3 oxide. Iron 3 oxide would be written Fe2O3 plus carbon monoxide reacts to produce iron metal plus carbon dioxide. Okay, we've got 3 oxygens here. 3 plus 1 is 4. If I have 3 carbon monoxides, that will give me 3 oxygens, plus 3 oxygens is 6. 3 times 2 is 6. I've got 3 carbons, 2 irons, and I need a 2 here. All right, so the first question, what is the mole ratio of iron metal to carbon monoxide? Here's iron metal. Here's carbon monoxide. Our ratio is going to be 2 to 3. What is the ratio of carbon dioxide to iron 3 oxide? Here's carbon dioxide. Here's iron 3 oxide. We have a 3 to 1 ratio. Next one, calcium hydroxide reacts with nitric acid to produce calcium nitrate plus water. So we're going to need 2 waters. And we'll need 2 nitric acids. So we have 2 plus 2 is 4 hydrogens, 2 oxygens, 2 oxygens, 2 nitrates, 1 calcium, 1 calcium. What's the mole ratio of water to nitric acid? It's a 2 to 2 ratio, which you could also say 1 to 1. What is the mole ratio of calcium nitrate to calcium hydroxide? Is a 1 to 1. All right, octane, C8H18, is the main component in gasoline. Octane reacts with oxygen in complete combustion to produce carbon dioxide and water. So, I know that we're going to need to double this because that hydrogen is 18, which divided by 2 gives us 9. We'll never end up with an even number of oxygens over here. So just start by doubling it. 2 times 8 is 16. We need 16 carbon dioxides. 2 times 18, we're going to need 18 waters. That gives me 16 times 2 is 32 oxygens plus 18, which adds up to 50, so I need 25 oxygens. What is my mole ratio of octane to oxygen? 2 to 25. What is the mole ratio of carbon dioxide to water? Carbon dioxide, water, 16 to 18. All right, we're going to stop here for now.